In today's video, we are going to learn about Reynolds number, the two types of flow, and the significance as well as the uses of Reynolds number. So let's start by learning what Reynolds number is. Reynolds number is a quantity in fluid mechanics that helps us predict the type of flow that is going to happen over a particular object. As you can see in this image, we have an object which is opposing the direction of air, and the airflow is turbulent and laminar. So Reynolds number basically tells us if the airflow is going to be turbulent or laminar. The formula for Reynolds number is the fluid's density multiplied by the fluid's velocity multiplied by the diameter of the pipe or the object from where the fluid is flowing divided by the viscosity of the fluid. Let's now talk about the types of flow. Flow are usually of two types, laminar flow and turbulent flow. As we already know that Reynolds number tells us whether the flow is going to be turbulent or laminar. But what is this laminar and turbulent flow? Let's first talk about laminar flow. Laminar flow is orderly, all streamlines are parallel and there is no mixing of fluids. As you can see in the picture right there, this flow of water is laminar as there is no mixing of fluid, and you can see that the water is flowing in a parallel streamline. Also, for laminar flow to happen, the Reynolds number must be more than 2300 and less than 2900. Here's a video of laminar flow that will give you a better understanding of it. Let's now talk about turbulent flow. As you can see in the picture, turbulent flow is more chaotic. The streamlines are not parallel and there is a mixing of fluids unlike laminar flow. Also, for turbulent flow to happen, the Reynolds number must be greater than 4000. Here's a video of turbulent flow. We now know what is Reynolds number and the two types of flow. But there are a few factors which cause turbulent and laminar flow. So let's now look at these factors in detail. The first factor which determines whether the flow is going to be turbulent or laminar is the viscosity of the fluid. Viscosity is nothing but the thickness of the fluid. For example, honey is a viscous liquid as it is a very thick liquid in nature. Viscous forces tend to keep the nearby regions of the fluid moving together. So high viscosity favors laminar flow. We can also see this in the equation that viscosity is inversely proportional to the Reynolds number. So if the viscosity is high, then the Reynolds number will be small, which causes laminar flow. The second factor is the speed of the fluid past a stationary object. The faster the speed of the fluid is, the more difficult it is for the viscous forces to keep them together, which causes turbulent flow. This can also be seen in the equation that velocity is directly proportional to the Reynolds number. The third factor is the size of the obstacle. The larger the obstacle, the more likely it will cause turbulence as the viscous forces will be unable to keep the fluid orderly. For example, water passing through a large rock will be turbulent, whereas the water passing through a tiny stone might be laminar. The final factor is the fluid's density. The denser the fluid, the less it responds to the viscous forces and is more likely to be turbulent. Now let's talk about the significance and applications of the Reynolds number. There are many significance and applications of the Reynolds number. We can identify the type of flow that is going to happen over a particular thing by just making a small model of it. A 4-inch Saturn V model was made to approximate the flow over the entire rocket. With this, we can also find out whether the flow is going to be turbulent or laminar. A laminar flow is advantageous, but a turbulent flow can sometimes be disadvantageous as it increases air resistance and noise. Thanks for watching this video. I hope you have learned something new about the Reynolds number and the types of flow via my video. So if you did, make sure to share this video and also write your suggestions in the comment section down below. And also, the next time you see water flowing through your sink, make sure to notice if it's turbulent or laminar.